I'm going to briefly review where we were before. If we're doubling every half hour, if t is in hours, then when t is 1/2, we've doubled. So we get this equation, which we easily solve to find that k is 2 times the natural log of 2. If t is in minutes, then when t is 30, we will have doubled. So p of 30 will equal 2p0. So then p of e to the 30k will equal 2p0. We run through a few steps that we've covered pretty well. Then we find that 30k equals a natural log of 2. K is natural log of 2 over 30. Now, in the example you're asking about, the video doesn't use the e to the kt model, it uses the p0 b to the t model. Now recall, instead of b to the t, we can use e to the kt. And remember, we use e to the kt if we want to think in terms of like continuous compounding. K would be the growth rate. That would be like our interest rate. If we're continuously compounding at 4%, then k would be 0.04. This is true if, and only if, b to the t equals e to the k raised to the t. Now this is an identity. E to the kt is e to the k raised to the t by the rules for exponents. And let me switch back here so I can see you okay. Okay. So the connection between the two models is that b equals e to the k. So there's a connection. Now if we're just using this model, it's easy enough. So we would say here that doubling time of a half hour or 30 minutes, whichever you prefer to use. Well, we'll use the 30 minutes because that's apparently what you're seeing. Okay. So then p of 30 would equal 2p of 0. P of 30 is p0 b to the 30, and 2p of 0 would be 2p0 b to the 0. We divide out the p0, and b to the 0 of course is 1, and we get b to the 30th equals 2. Okay, so b would be 2 to the 1/30th. And we wouldn't have to use a natural log. In this case, since now b is 2 to the 1/30th, then b to the t is 2 to the 1/30th raised to the t. So we get P naught times 2 to the T over 30, which is what you were seeing.
Now it makes sense. Thank you.
I'm glad it makes sense, and glad that helped. Okay, so yeah, I can see where you'd be a little confused by that. Since I was using the e to the kt model, and what you were asking at was a b to the t model. They're both good models, and there are advantages to both. In this case, you get 2 to the t over the doubling time. In other words, when t equals the doubling time, that's when you have a doubling. And that's a handy way to look at it. If you want to, yeah, so it depends. Do you want to think in terms of the growth rate? Or do you want to put it in this form? And of course, you can get the growth rate from this form. And I believe the example you have in your video does that. Okay, so B is 1 plus R, where R is a growth rate, and B is the growth factor. For example, if you had at 4% interest, your multiplier the growth factor is 1.04, 1 plus the growth rate, as we saw with the early examples in compound interest. Okay, that connects the B to the K. The K would be your R, your growth rate. So K's growth rate and B is a growth factor. Okay? Okay, very good.